All right, you ready? So this is like the second part. The first part's already posted on Google Classroom. So this is like part 2 of review number 1. All right, so let's review some of our transformation rules. Okay. If I'm inside a mathematical symbol, if I'm inside that mathematical symbol, which way do I go? Yeah, it's opposite the sign. I go left or right, though, all right? Left or right. And I'm going to go opposite the sign there. And what I mean by that is you look at the sign and you see +3. You're thinking, hey, I should go to the right 3. But you got to go opposite the sign, okay? When you have a plus sign there, you're going to go left. When you have a minus sign there, you're going to go right. That's what I mean by opposite the sign. What about that 2? Outside the mathematical symbol.
Up or down, you have to follow.
Yep, up or down. And you have to follow that sign. So I got a +2 here, so that means I'm going to go up 2. Now, we do have more transformations, right? In fact, we have 3 more transformations, and they all deal with that slope that's out in front. Remember, this isn't kind of like in vertex form here, right? Y equals A times the absolute value of x minus h plus k. Now that A has 3 more transformations. Now we're lucky here because it's a +1. So there's no transformations for the A. But if I did have an A there, it would either reflect, right? If it was negative, it would reflect. If it was a fraction between 0 and 1, it would contrast or make it wider, right? And if it was a number bigger than 1, it would stretch or make it skinnier. Okay? But fortunately, we don't have to deal with it because the A here is 1, or the slope is 1. Okay, my vertex also, out of that formula, my vertex is h comma k. So when I go to graph these and they ask me what the vertex is, well, it's actually not that hard because my vertex is hk, which equals, well, my h here is +3. Remember, I have to use opposite the sign. So it's -3. My k is +2. Same sign. So there's my vertex. My transformations, well, I have to go left 3 and up 2. So I'm going to go ahead and graph that. So my vertex is -3, 2. So I'm going to go -3, 2. And then my slope here, I already said, was 1. So I'm going to go up 1, over 1, up 1, over 1. So here's my right side of the V for the absolute value. Remember, absolute values have a line of symmetry. So I'm going to have the other arm of the V going this way. So there's my graph. Questions?
For inequalities, if it's a greater than sign, that
Say that again?
The inequalities, the greater than sign, is it and?
If it was an inequality
I'm saying again, for inequality.
for inequalities, it would be a kind of a different problem. Inequalities are different.
I'm asking about inequalities.
Oh, let me get back at when I'm done. I'll go back and do some inequalities. Okay. Number 10. I'm sorry, I didn't quite understand. Number 10. They're asking us to solve for the various variables, right? Different variables. What I like to do is they're asking, hey, solve for A. I like to go and circle the A's where they are so I can get a starting point. If we're going to solve for the A, I should have the A's on the same side of the equal sign, right? So I'm going to bring this 5A over to the other side. So this is a positive 5A. So I'm going to subtract 5A from both sides.
Why not divide?
Well, if I divide the 4 by A, nothing's going to cancel out, and I'm going to have a fraction to deal with. Okay, could you divide by A? Yeah, you could, but it's kind of going to become a really hard problem. So I'm going to get it on the same side first. And we are eventually going to divide by A. Hayden. Okay, so I've got my AM minus my 5A. Do not combine these. These are not like terms. These cancel out, and I have my 4 on this side. Now, this is where I'm going to divide by my A. Because I have A in 2 terms here, right? I need to divide that out of there. And we called it, we had a name for it. We're going to take that A out. We called it undistributing, right? So I'm going to have parentheses here and my 4 over here. So actually what I'm doing is I'm dividing A out of each term. So AM divided by A leaves me with M minus 5A divided by A is 5. Okay? Now I have one term because I just made a quantity here, and now this is a number and that's a number. It's being multiplied. Now I'm going to divide this one term by everything I don't want. And what don't I want with the A? Well, I don't want this M minus 5. So these cancel out. My A is going to equal 4 divided by M minus 5. Okay?
I have a quick question on IB. Do we flip it? Like,
No, you're not going to flip it because your A is positive. Okay? All right, let's look at some exponent rules. Now there's what, 5 problems here, and there's some different exponent properties that we have to deal with on each one of these. For some reason, students don't necessarily like exponent properties. So let's look at the first problem here. When I have division, and all of these are division, right? I like to look at the numbers separately. I'd like to think of these as each their own fractions. Then I have my x's, and then I have my y's, Bless you. Okay. So I'm looking at my numbers. I have 10 12s. Not much we can do about it, but we can simplify it, right? And if you are not that good with simplifying, just put it in your calculators and hit math enter, right? I could take a factor of 2 out of each one of these. 10 divided by 2 is 5. 12 divided by 2 is 6. Now I take a look at my x's. I have x to the 3, and it's division, so I'm going to subtract my exponents, and my bottom one has a negative 9. Yeah, you end up adding it because you have a minus minus, so I have x to the 12. No, it's a positive 12. Goes up on top. Okay. Now, I'm going to look at my y. My y has a positive exponent here, so I'm just going to leave it where it's at. So I have y to the 7. Okay? That's it. I'm done. All right, the second problem. Again, split up your fractions here. Here's my numbers. And my y, I only have a y in the top and I have an x in the bottom, so I don't need to circle those. Can I simplify 5/3? Nope. Let's see, my y has a positive exponent, so it stays where it's at. Y to the 9th. My x has a negative exponent. Yeah, I'm going to put it in the top and make that exponent 12. Oh, I'm sorry, 2. 2. My fault, 2. He really took me literally when I said spread them out on the floor instantly. So there's my answer. Okay, the next one, we have a number outside of the parentheses. So technically, there's a 1 there if there's nothing there, right, for an exponent. Technically, I should multiply each one of these exponents by -1, but it really isn't going to change the exponent number itself, right? So they're all going to be negatives, and how do we get rid of negative exponents? Yeah, we just flip them. So this is going to become my numerator, 2x to the 5th, and then this is going to become my denominator, 7y to the 4th. Pardon me? The exponent for the 7 becomes negative. Because when I take the 1 times -1, I get 7 to the Here, let me do this. Okay, this becomes 7 to the -1, y to the -4, over 2 to the -1, x to the -5. So now that everything's negative, I have to flip the whole fraction so that all the exponents become positive. Okay? Now the next one's a little bit different, and we didn't do rational exponents this year. However, I did touch upon what this 1/2 means, right? Again, you would have to distribute this to every, there's a 1 here, there's a 1 here. You should multiply each one of these by 1/2. In fact, maybe we'll do it that way. Okay, so I get 25 to the 1/2, x to the, what's 8 times 1/2? What's half of 8? 4. 49 to the 1/2, and then y to the, what's half of 10? Half of 10. Now, I still have to get rid of those 1/2 rational exponents, right? What does anybody remember what that exponent of 1/2, another way of writing it? What does it mean? When I have an exponent of 1/2, I can write it as a square root of that number. Okay, so I actually have the square root of 25 and the square root of 49, which if you look at that flow chart that you can use on your test next week, these are perfect squares. So the square root of 25 is 5. And then I have x to the 4th, right? Square root of 49 is 7. And I have my y to the 5th. Yeah, exponents, like I said, there's a lot of properties, there's a lot of steps, a lot of detail, and a lot of, it's kind of like PEMDAS. You got to follow it to the T, okay? All right, let's look at the last one. Here's my numbers. Here's my x's. And then my y's. Okay, how do I simplify 5/50?
5/5.
Yep, so 1/10. Let's see, I have an x to the 8 minus 7. Gives me x to the 1st. Where's that going to go? Yep, just x up in the numerator because it's a positive one. And then I have my y's. So I have y to the 2nd minus 6. Gives me y to the negative 4th. Where's that going to go? Careful. Yep, it's good. Oh, no, it goes to the bottom. You were right, Mason. It goes to the bottom. Because if that's over 1, I need to flip it, right, to make it positive. So it needs to go in the bottom. I did do it wrong on my last class. Okay, questions on the exponents? Okay, next, factoring. Everybody's favorite. Factoring. My coefficient is 1 for the x squared, so I'm just going to go ahead and go straight to my factors. How do I get x squared? Well, good. X times x. The factors of 30. Let's see, 1 times 30, 2 times 15, 3 times 10, and 5 times 6, right? See, it's a negative 30, so 1's going to be positive, 1's going to be negative, which means I'm going to be subtracting these factors. 310 works, yep, because 10 minus 3 is 7. Now I got to figure out where those minus signs and plus signs go, right? So the inner is 3x. The outer is 10x. I want them to add up to negative 7x, which means our bigger number has to be negative, right? Smaller number has to be positive. So my 3 has to be positive, and my 10 has to be negative. Okay, and 13. Now, we only did a couple of these problems. We did a lot of completing the square, but we only did a couple where we had to put it in vertex form. And vertex form was A equals A times x minus h squared plus k.
Yes.
So completing the square, remember, for step 1, I have to have, in this case we keep the y because we're going to put it in vertex form. So I'm going to have my y plus c equals ax squared plus bx, right? If I didn't have the y there, we did a lot of these, but since we're putting it in vertex form, we're going to keep the y there. So I'm going to, here's my c plus 20. So I'm going to get it to the other side, minus 20, minus 20. So I have, I'm going to keep my y minus 20 equals, these cancel. I have my x squared minus 6x. And remember, we're going to add a perfect square, b divided by 2 squared, right? So I need to add a perfect square, which means I'm going to have to add a perfect square over here. My perfect square, I'm going to take my negative 6, divide it by 2, square it. So I get negative 3 squared, which is 9. Okay, I'm going to rewrite it up here. That y minus 20 plus 9 equals x squared minus 6x plus 9. Okay, so I have y minus 20 plus 9. Good, minus 11. My perfect squared trinomial factors to a perfect square binomial where I have x and my base was negative 3. Now all I have to do is get that y by itself, right? Y by itself. So I'm going to add 11 to both sides. And my answer, my final answer, is x minus 3 squared plus 11. And there is part 2, day 2, right? We good? I'll do that on Monday. If I'm not here, then maybe Mrs. Meyer can go over it, a couple of the problems. Okay? If you want to start, I just want to, again, make sure that you guys have it. Because I'm not the most organized person to have them all printed off and ahead of time. So it helps me more than you, I guess. Okay, so that's part 2.
Wait, I think we also didn't do 5A and 5B.
Yeah, let me go back.